Japan built a wall so massive most people on Earth have never heard of it. It is taller than a 4-story building and runs for 400 kilometers along the coast. This engineering marvel cost over $12 billion to protect the nation from future disasters. 400 kilometers is the distance from New York to Boston and back twice. Every inch of it was built by hand to ensure the tragedy of 2011 never repeats. That was 2011. The wall exists because of what happened on that devastating day. See where the waves hit. Now it's peaceful. Wait, this wall is now so high you literally cannot see the ocean from your home. My husband ran toward the sea. I never saw him again. I never thought I would see a world like this. It is a harsh and lonely place now. Every meter of this wall was paid for in grief. Now watch what they actually built. But engineers warned, if this wall fails, it could make the next tsunami far deadlier. March 11, 2011. The ocean floor moved 50 meters in just 3 minutes. That rupture displaced 500 cubic kilometers of ocean, creating an unstoppable force. Not a wave, but a moving wall of black water, 40 meters tall. 90% of Japan's sea walls failed in that single hour. Every engineer took notice. The world's largest breakwater, costing $1.6 billion, was destroyed in seconds. It did not break from the front. Water topped it and eroded the back face. One mayor, one wall, 3,000 people alive. That village gave Japan its blueprint. The plan was simple but massive. Build it taller and stronger than ever before. How do you design a wall to stop an entire ocean? Here is the truth. This wall was never designed to stop the 2011 scale wave. Most of it is underground. Engineers modeled this wall 200 times in a computer before placing a single stone. Wall height changes every kilometer, taller on exposed headlands, lower in sheltered bays. 440 separate teams. If even one goes bankrupt, a gap opens in the wall. Before one stone is placed, survey ships drill the seabed. Every section is different below. 3 foundation types: soft clay, dense sand, hard rock. Each requires different engineering. First task: demolish the walls that failed. Study every failure mode to build better. 400 kilometers, measured meter by meter before a single machine starts digging. This step takes months. Precision is the only way to ensure the wall's integrity. They cleared an entire coastal pine forest. Erosion matting follows the bulldozer within minutes. Always. The tide gave them only 4 hours daily on the seabed. The ground is dangerously soft down there. Steel road plates spread the load. The machine floats above the mud. Simple, effective. Crisis over. They are building the foundation 25 meters below sea level in the active surf zone. Divers guide 5-ton boulders into position underwater in the same ocean that destroyed the coast. Engineers check the underwater progress by sonar. They must trust the data completely. Between boulders and fill sits a filter layer. Miss it, the wall slowly bleeds away. After weeks underwater, the rubble mound breaks the sea surface. Watch what comes next. That geotextile membrane stops fine soil particles migrating into the rubble. It works forever. A 1 to 1 in 5 slope angle exactly. Steeper and boulders slide, flatter and waves won't break. A platform is rising inside the ocean from nothing. Now the real wall construction begins. Sheet piles driven 10 meters into the ocean floor just to protect the wall toe. Z-profile interlocks. That connection transfers shear forces between every pile in the wall. That steel wall fights the retreating wave, not the arriving one. Backwash destroys foundations. Pre-drill the boulder first, crush it. Then the pile drives straight through the cleared hole. The wave going back out is more dangerous than arriving. Backwash pulls the sand out. 30 dump trucks running 16-hour shifts non-stop. One breakdown stalls the whole cycle. 300-millimeter lifts, no more, no less. Too thick and compaction never reaches the bottom. Geotextile reinforcement layers, like rebar in concrete, but for compacted fill inside the wall.
So it makes sand strong?
98% proctor density, or the inspector shuts the job down. Every layer is tested. Press your foot on 98% fill, nothing moves. At 85%, it sinks. 300 millimeters per day. 18 months until the first tsunami season with the wall. That clay core is the wall's internal waterproofing. Well-compacted clay stops water permeating through. One night of heavy rain, 600 millimeters of slope slumped. The section is rebuilt. A drainage pipe network inside. Cover the slope with geotextile before every rain, always. The wall hits 10 meters. Thousands of concrete panels are coming. This is the critical part. This wall has sensors embedded inside. Engineers watch it breathe and settle every day, forever. The face must be perfectly flat before any panel goes on. One bump creates stress. 3 materials, 3 jobs. Grip the seabed, seal against water, carry the structural load. 7-ton panels. If even one cracks, it ruins the schedule. Every bar connects to the wall. 400 kilometers of protection. Japan's wall stands ready, a testament to human engineering.